Welcome everyone to the after party. The secret is out, the big reveal has happened. You met the tech, now meet its makers. Our after hours event is intended to give our audience an outlet to ask the juiciest questions and have our engineering best answer them. Now, you may know me, but for those who don't, my name is Emily DeSimone and I'm the Director of Global Marketing here at SLM Solutions. We are thrilled that you've made it this far and have decided to join us for this live discussion. To the newbies, welcome. To our current customers and fans, we're glad to have you. Let's dive in. So I am joined by our very own CEO, Sam O'Leary. Sam has been CEO of SLM Solutions since January 2021. He was previously COO of SLM Solutions and was responsible for production, product development, R&D, as well as supply chain management. Prior to this, he served roles at Alstom and GE and SCOR Group. With Sam's young mindset, he's putting an innovative twist into the company. Welcome, Sam.
Thank you, Emily. Good morning, good afternoon, everyone.
So now let's meet our best of the best, SLM Solutions' finest engineers. Let's introduce them now. So in addition to Sam O'Leary, we have joining us Dr. Dieter Schwarzer and Benjamin Haas. Dr. Dieter Schwarzer is one of the early pioneers in additive manufacturing. He started his journey in additive manufacturing in 1989, working on R&D and the commercialization of additive manufacturing. He's the co-founder of the widely used selective laser melting technology and holds several patents in this field. In 2008, he joined SLM Solutions in Lübeck as head of science and technology research. Dr. Dieter Schwarzer studied physics at the University of Paderborn, Germany, and is a member of the board of directors of Directed Manufacturing Research Center at the university. On May 8th, 2017, he was honored with the SME Additive Manufacturing Industry Achievement Award at Rapid TCT Conference in Pittsburgh. Welcome, Dieter.
Hello, Emily. Good morning and good afternoon to everybody.
And finally, Benjamin Haas. He's passionate, creative, technology-inspired product manager with a passion for combining material science and customer-oriented products, with the goal to create products to satisfy customer needs ultimately. Focus areas include product strategy, material development, market research, data science, and product marketing, just to name a few.
Just a few, yeah. Hi, everyone. Good morning and good afternoon to each and every one of you. Thanks for joining.
So now that you've met the makers and we've introduced them, let's open it up to questions from the audience. For those participating, please comment on YouTube and our behind the scenes team will funnel questions. Looks like there are several questions already coming in, so that's great. That's a good start. But as they trickle in, just keep them coming. Panelists, I will do my best to funnel the question to the appropriate individual, but feel free to add any additional info onto your colleague's answer. Let's start. So we all just watched the video. In the video, we claim a minimal angle of 5 degrees. Is that a general figure or only under certain circumstances? Dieter, I think you're going to be the best one to take this one. Oh, wait. Dieter, I don't think I can hear you. There we go. Oh.
Figure. The angle always depends on the geometry and individual part design, as well as on the thermal, let's say, capabilities of the material, as we have seen in the launch video already.
Dieter, do you mind just repeating that beginning part of that for those that might have missed it? I think there was a lapse in the audio. Thank you.
Well, the 5 degrees angle is not a general figure. It depends on part geometry and on individual design of the part, as well as on thermal capabilities of the material that is in use.
Perfect. So why not 0 degrees?
Well, that would work as well. But right now, it's not relevant for any industrial application. You could do that, but only for very, very short ranges of let's say, overhangs. Free float means that something is standing free in the room. So it is connected to a base body, but it's standing free in the room. So if I would produce a totally horizontal area, which is supported at the circumference, this is possible, of course. But from the industrial point of view, it's irrelevant.
Thank you. Benjamin, I think I'm going to have to get this question over to you. So this is not the first that we've teased this new product out. And so the question is that you showed the first demonstrator at Formnext 2018. What took so long, Benjamin? Why 3 years later?
That's right, and I'm happy that I was at Formnext 2018, so I actually saw these parts right standing in front of me. So yeah, what took so long? So in 2018, we really showed the very first demonstrator, and people were really fascinated by that already. And so the industry feedback has been tremendous. So whether it's aerospace, energy, automotive, so all customers pretty much of ours really saw these parts, and the first and foremost question was really, when can I have it? But we wanted it to take a little bit longer and just keep it under the curtain for now, because we wanted it to be an easy to use solution. Because the technology that we invented is of course already, let's say, applicable, not necessarily with the software package that we've created, but we specifically wanted that software package because we wanted it to be as easy as possible for our customers that, PhD material science is actually required to use it. So we have came up with a completely new software interface that does exactly that. And that, of course, takes some time. So if you try to reduce something to the minimal, that's probably more complicated than just adding stuff to it. And also that very first demonstrator was out of steel, just because it's been around and we made several trials at the beginning. But since we had such a good customer feedback already at the beginning, we started deepening these discussions, and we pretty much saw at the very beginning that steel definitely has its right to be there, but the most industry applications that would benefit from free float are actually in the, let's say, space, aerospace, energy sector, and here the materials are a little bit different. So that's why we also started developing free float for titanium and Inconel as starting materials, and all of that, bottom line, took us roughly 3 years.
All right, thank you. I haven't seen this question come in just yet, but since we're on the topic, Benjamin, I'm going to stay with you for a second. You mentioned the availability and delivery of the product. When can you get it?
Right. So today is, of course, the official launch. And as you might have seen it in the video, we'll offer it for both new machines as well as for our installed base machines. So while we're currently doing the final touch-up for the software, this means the software will be shipped in Q4 of this year. But of course, it's ready to order now for new machines.
Perfect. Thank you. So I see several questions. This is going to be a hot topic, and I think Dieter is the only one that can really address this one. So Dieter, I'm going to switch it over to you. How does your solution differ from competitor solutions? On my feed, I'm seeing EOS, Phalo 3D. So can you answer that? How does our solution differ, and what ultimately can you expect that may not be being met by the current marketplace?
Yeah, okay, very well. We have, I think, a lot of experts in the audience, and to those, they know how it can be done. There is different ways to do that. One way is to modify the energy input in terms of a laser on, laser off. This is also called pulse laser energy deposition, energy deposition. But this means there is time when the laser is on and there's time when the laser is off. And this is slow. This really slows down the process to, let's say, a factor of 10 or even more. So it is not productive. Also, the point-to-point exposure style that is used by different people and machine manufacturers is taking productive time to a limitation to a very low figure. So productivity is not reached with their approach. So once again, we have the pulsed energy deposition or the pulsed laser exposition, and we have the point-by-point procedure. This point-by-point procedure means that the scanners will jump to one point, expose it, jump to another point, and expose this point. But there is a distance in between, and which has not been exposed. This will be done at a later stage. So it is a discontinuous point-by-point exposure. This is time-consuming. And this is, once again, the reason why this is not the way that we have chosen. It was no option for us. And so we have chosen the continuous approach, and we were successful in doing so.
Great. Thank you. I think that answered several questions that are coming through the feed right now. So thank you. Sam, is there a black box involved, or can I fully manipulate my process?
No, it's a great question. No black box. You know, we talk an awful lot about open architecture, and this is no different. The profiles are fixed, but the parameters are completely open. Of course, we ship with a particular parameter set, but you are free to manipulate that as needed.
And I think this is another question for you. Are you really giving this away for free? What is going on here?
You know, I'm just too kind, I guess. Now, look, this is a cool new technology we think can help our customers, new customers and existing customers, enable and do more with their machines. So this is our starting approach to this product, to have the initial features available to all and to add value for our customers.
Great, thank you. Benjamin, we're going to throw it back over to you. Do you have FAA approval for free float?
That's also an excellent question. And so the answer is no, not yet. Even though we've spent the last 3 years working on free float, and usually the FAA regulatories also take their time, we are in close contact with customers who are active in that field, and they're getting, or we are in a very close exchange with these customers on talking about these parts. How can they be used and regulated by the FAA? So no, not today, but we reach out to these customers proactively and try to get a better understanding of what's necessary. I personally don't expect any difficulties here, but in the end, the FAA should approve it, and that's why we reach out to companies in that field proactively.
Great, thank you. Dieter, does this mean I can build without any supports at all?
No, it does not mean that. But it is possible that you can reduce the number of supports to a very, very large number. So it is our goal to reduce the necessary amount of supports to a minimum. And this is what we have achieved.
Great. Benjamin, throwing it back over to you, sorry, but why did you choose Inconel 718 and TIE 64 to start with?
Yeah, excellent question. And so I mentioned that we started working on steels just because they've been around and we've made our very first trials with it, and they were very successful already in the very beginning. But the more we talk to customers and the more we try to sort of get a good feeling of the market potential that free float actually has, we really saw, okay, it's really in the aerospace, space, and energy department where they just have the right applications for it. If you think of turbine blades or impellers where you just can't get right into the part to remove supports manually, that's really where the huge benefit of free float comes in very, very handy. And these applications usually run on Inconel or TIE 64. And that's why we've decided to launch it with these two materials, but more to come.
Great. I think that also answered Paul from 3D Printing Industries' question regarding what aerospace parts in particular. So, so we really have listened to the customers to understand what the marketplace need is, and that was reason for the prioritization of the material.
Maybe just one thing to add. So despite the fact that we are mainly talking to space, aerospace customers, I think with the light hinge that we already saw during the campaign, that part has been around for several years already. I think Dieter, you brought it with you several years ago already, and so this is not a new part at all. But we wanted to show that free float is also beneficial for existing designs, so that you do not necessarily need to start redesigning your existing part, but it already adds a lot of benefit to your existing geometries just by removing a lot of the support structures, and therefore making the part itself, but also the production process way better and way more efficient.
So it sounds, again, I haven't seen this question come through, but it sounds like what you're saying is this product is really industry agnostic, and that you would expect it to enable success for automotive, medical, and so on. Is that correct?
Exactly, yeah. And as a matter of fact, so since you mentioned medical, so just a couple of weeks back on our SLM 800, we had a very cool build just with medical parts out of Ti64 using free flow technology. So yes, it's definitely industry agnostic, but as a product manager, of course, it's also part of my work to really identify the largest interest in the market, and that's definitely right now in space and aerospace. But applying it for all sorts of parts is definitely one of the key benefits of free float.
Great. So you said that you started with Inconel 718 and Ti64 to meet marketplace demand. But when will I be able to work with the rest of the material portfolio?
Yeah, so as a matter of fact, our material portfolio is quite extensive. So really ranging from various steels to copper alloys, of course, the nickel, the titaniums, and of course, aluminum. So we actually have made very, very clear to, well, for us internally, that in the roadmap for free float, we're adding new materials over time. So that means that as a minimum, we're adding 2 new materials every year. We do have some hot candidates already identified for these materials, but we are very, very open for industry feedback. So if any of you have a specific material to combine with free float, we're happy to hear your feedback. But we'll definitely add more materials to come.
Great. And why just 1 layer thickness?
That's a very good question. So we're starting with a 30 micron layer process. During the development phase, so during these 3 years, we've also looked into several other layer thicknesses, but we then decided, okay, it makes more sense to offer just more materials with 1 layer thickness instead of just adding 1 material with several layer thicknesses. So we wanted it to keep as broad as possible to address as many markets as possible. But the same what I just said for materials really just counts for layer thicknesses as well. So already with that 30 micron process, we're able to boost productivity. And I think we are quite famous in the industry for very productive machines in conjunction with very productive parameters. So I think the way is quite clear what we're heading towards, but we're starting with 30 and then add more as we speak.
Great, thanks, Benjamin. We'll let you get a swig of water to rest your voice for a second. Sam, I will shoot it back over to you. Will this be available on NXG 12600?
Yes, of course. I mean, this is one technology to add to our already groundbreaking machine. So it's for our existing portfolio and, of course, for the NXG 12600 too. Great,
thank you. And you were discussing the different profiles. I feel like you might be best for this question. What are really the differences between, we're getting a lot of questions around the downskin parameters. So would you be able to speak to the differences between those parameters and the free float technology?
Yeah, absolutely. I would, but I would do this a misservice. I would hand over to Dieter, who would give a far better explanation than I would.
Yeah, okay. We will not talk too much about it, but of course it is a combination of, let's say, the findings that we had over the last 4 years and let's say, a manipulation of the laser parameters. So it's clear if you're going into a downskin region and you apply the same laser power that you apply for the solid, that will not work. It will lead to overheating and the discoloration of the material. looking at the light hinge that we saw in the launch video, this wasn't done with aluminium. This was done in stainless steel, without any discoloration. But this is possible with the combined, let's say, parameter approach that we found in free float. And as Benjamin already said, it takes a lot of time to develop those parameters for every and each layer thickness. And so our customers have to be a little bit more patient with us, and then they can adopt the technology also afterwards for larger layer thicknesses. I'm pretty sure that we'll reach that goal as well.
Well, certainly. I nailed it directly into the roadmap, so it's set in stone. And maybe just one thing to add for the profiles. So when we were discussing that we really wanted to make it as easy as possible for our customers, maybe just talk a little bit on the workflow, so the way free float actually works. I mentioned it during the video, but you really start with your SLM file, and you then add these so-called profiles. And during the development, we found out that there are basically several different things that you want to do with your part. So let's say in the most extreme case, of course, you want to reduce supports or just remove supports. But in some cases, just some surface finish touch-ups are necessary, or maybe you would just want to avoid subsurface porosities. And so this is why we've come up with different profiles that do exactly that. So to speak, the low profile, they're basically called low, medium, and high. So the low profile would literally just reduce a little bit the surface roughness and increase part quality, and then medium and high are really then the profiles you apply for the part to reduce the support structure. So maybe just to add that as a comment.
Thanks, Benjamin. Thanks, Dieter. There are a lot of questions in regards to more of our commercial strategy behind it being free. Sam, I know you said that you're being very kind, but is there more of a visionary answer as to why this is not going to directly impact our revenue in regards to a product commercialization value?
Well, of course, it will impact our revenue as a kind of individual entry product. Of course, as we've already said, this will be free of charge as an entry product. Now, there will be additional features, of course. But as I said, what we're doing here is looking to open up new applications, new possibilities for our existing and new customers. And that, of course, leads to greater usage of machines, more machines required, more application cases. And therefore, for us as a supplier of these machines, greater numbers of machines sold. And that is the driver here, to really open up, create more application cases, and to deliver more value for our existing and new customers.
Great, thank you. There are also a few questions regarding the magic behind the product, and I think no magician will ever reveal its best trick. So we'll keep some of that to ourselves. Sam, do you want to, while we're with you, do you want to say any closing comments regarding this new launch?
No, I think we've had a great deal of fantastic questions. I think you're absolutely right about not revealing the secrets behind the magic. We should focus on of course what this can deliver for our customers and what this can enable. Myself and the rest of the team, we look forward to further detailed discussions with our existing and new customer base, and look forward to rolling this out and seeing the impact that it has.
Great, thank you so much, Sam. Thank you everyone who participated in today. There's questions still coming through, which that's great, and thank you everyone for participating. We will wrap it up here. Should we have not been able to get to your question, or should there be additional questions, always reach out to our experts. Feel free to submit them. You can see on the banner here below where you can get more information. But thank you everyone for joining, and I hope you have a really great week, and thanks for participating.